Today we're going to cover continuity and discontinuity. So continuity. A continuous function has no breaks, holes, or gaps. So what that really means is that you can put your pencil on the function and you can trace the whole thing without lifting your pencil. So if we have a graph and we are unable to trace the entire function without picking up our pencil, then that means that we have a discontinuous function. There are three types of discontinuous functions. The three types are infinite, jump, and removable. So I'm going to give you a visual example of each. The infinite, I'm going to draw an asymptote, and I'm going to label this spot C. And I'm going to do a function where as we approach x is equal to c, so this c value here, so the graph is either increasing or decreasing towards infinity. So I wrote below, at x equals c, the function increases or decreases infinitely as x approaches from the left or from the right. So if we're approaching c from the left, and I'm following along the graph, we're going towards negative infinity. And if we approach from the right towards x is equal to c, we're going towards positive infinity. We are unable to trace both parts of the graph without picking up our pencil. For jump discontinuity, I'm going to draw an example. Again, I'm labeling C, and at C, the limit exists, but it has two distinct values. So what does that mean? It means that if I'm approaching C from the left-hand side, my y value is some negative y value. If I'm approaching C from the right-hand side, the y value in this example is a positive y value. So the graph is jumping from one line to another line, in this case, at x is equal to c. The last one is removable. So this function is continuous everywhere except for at c. So imagine that I'm following this line, and then all of a sudden I have to jump over a hole, and then I can continue on the same path. That's removable. So I'm going to give you a process where we identify continuous functions or discontinuous functions. And when we determine if a graph is discontinuous, we also have to determine what type of discontinuity it is. So in this video, I'm just going to outline the steps and then we'll practice when we're together. So make sure that you take really clear notes so we can refer back to them. When we do a continuity test, the first question that we have to answer is f of c defined? The second thing we're going to do is we're going to make a table. And we're going to see if f of x, which is really our fancy word for y, approaches the same y value from each side, meaning the left side and the right side. So when we are determining if the graph approaches the same value of y from the left and the right side, what we're really asking is, does the limit of x approaching c of f of x exist? Now this is going to seem a little bit confusing, if not completely confusing, and that's okay. I will definitely fill in the gaps. Just write it down. So this notation here in words is the limit as x approaches c of f of x. Then the last thing we're going to do in our continuity test is we're going to make a conclusion. So we're going to write as a limit, if that's possible. And if it's continuous, we'll write the limit as x approaches c of f of x is equal to f of c. Now this may not mean much to you right now because we haven't applied it, but just make sure you make good notes so we can follow them step by step when we're together.